In this episode, we are going to begin talking about the concept of stoichiometry. Big long word that literally means chemical measurement. In this particular chapter, we're going to learn how to do things like, let's say I start with a certain number of grams of a reactant. I want to know how many grams of a product are made. We can, one, calculate those things, and two, in the laboratory, we'll be able to mix these chemicals together and determine and accurately measure how much stuff we get out. In this particular episode specifically, we're going to learn the right mole ratios and perform stoichiometric calculations. The first of which is just moles to moles, and we'll save the masses for later. So let's take a look at a sample based on a chocolate chip cookie recipe, because this really is just stoichiometry. It's a way of measuring things. Here I have my recipe. I got all my stuff, making a grand total of 5 dozen cookies. My question to you now is, if I have 5 eggs, how many cookies can I make from those 5 eggs, assuming I have enough of the other stuff? Well, a lot of you can work this out in your head. Well, if I had 4 eggs and enough of the other stuff, I can make twice as many cookies, so that would be 10 dozen. And if I had one more egg and enough of the other stuff, I could make another half of 5. That's 2.5. So 5 plus 5 plus 2.5 is a total of 12.5 dozen cookies. Some of you would want to sit down and make a proportion, which is fine. There's nothing wrong with that. You set up your proportion of, okay, well, 5 dozen cookies is to 2 eggs. 5 dozen cookies is to 2 eggs. As how many dozen cookies is to 5 eggs? I got my unknown on top, which is the way you should try to write all of these. Remember, your proportions are set up. Oops, sorry about that. Your proportions are set up so that your same stuff is on the top or the same stuff is on the bottom. So dozen cookies are on top of both, eggs are on the bottom of both, because they're supposed to be equal. How do you solve this? Multiply the 5 over. 5 times 5 is 25, divided by 2 is 12.5 dozen cookies. In chemistry, though, we're going to be using slightly more steps than this, and so it's to our benefit to learn how to do this using our conversion factors. And the conversion factor that we're going to use is the same conversion factors we've done before. The 5 eggs is my given. Set up a parenthesis line parenthesis. I want to get rid of eggs, so eggs go to the bottom. I want to get dozen cookies on top. The numbers that you get for this are coming now from my recipe. The givens. 5 goes with dozen cookies, 2 goes with eggs. Solving this is the exact same way you solve the proportion. 5 times 5 is 25, divided by 2. 12.5 dozen cookies get made. So we can sometimes look at the recipe and tell what's going on. We can set up proportions a lot of the time and figure out what's going on. But from a chemistry standpoint, it's a lot easier to go right to your conversion factors. Let's take a look at what the chemical recipes are. You've seen these before. They're chemical equations. In a chemical equation, this says I have to start with 1 mole of carbon dioxide and 2 moles of lithium hydroxide. And if I start with those, I will get out 1 mole of lithium carbonate and 1 mole of water. But you and I both know that you don't always start with a whole number of moles of things. Remember, moles can be decimals. So what happens instead? We start off with 4 moles of lithium hydroxide, twice as much. Well, that means I need twice as much carbon dioxide. I would need a grand total of 2 moles of that. And how much stuff gets made? Well, I make twice as much lithium carbonate, 2 moles and 2 moles of water, if I double this. So now you can kind of see how the moles tell you how much stuff you get. And then based on how much stuff you get, we can convert those now into grams in a fairly easy process. And again, this is going to bring stuff together from Chapter 2, our chemical conversions, all the way through naming compounds and chemical equations. So it's like everything we've learned this year is coming together all in one big thing. Let's look at how to use a mole conversion to do this. Here's another chemical equation. Mercury oxide breaking down into mercury and oxygen gas. And our balanced chemical equation, which you must always start with, is a balanced chemical equation, is 2HGO plus 2Hg yields 2Hg plus 1O2. If I've made 0.75 moles of oxygen, how many moles of mercury got made along with it? Well, this is just a standard conversion factor. 0.75 moles of O2 are what we're starting with. Now, a lot of you can just do this in your head and say, well, if I made 0.75 moles of O2, I make twice as much mercury. So twice of 0.75 is 1.5 moles. So in your head, you can already know what this is. But from a chemistry standpoint and from a conversion factor standpoint, here's what we're doing. I've got moles of O2, and notice how I'm being specific about what substance I have now, because now we're dealing with two substances. We're not just comparing one substance like before, we're comparing two different ones. So I want to cancel moles of O2, so moles of O2 goes on the bottom, and I want to know how many moles of mercury go on top. The numbers come from the equation. 2 goes with mercury, 1 goes with moles. 0.75 times 2 is 1.5 moles of mercury. Fairly easy calculation. Now you can kind of see how well now I could figure out how many grams of oxygen I made, and I can figure out now how many grams of mercury I get out. Those are steps you already know how to do. Let's talk about the first of these. We're going to highlight these in some detail. And as we go through these, one of the things I'm going to do for you is I'm going to give you this little helper. And this little helper, this stands for grams, and the arrow is the direction I'm going. I'm going to moles, and then from moles to moles, and then from moles to grams. And on every one of these problems we do here on the board, I'll have this grams to moles to moles to grams. It's not a mnemonic, but it's a little remembering device that you can use. The left side, which I have boxed off in pink, and the right side that I've boxed off in pink, this left side is one substance, and the right side is another substance, but they're the same substances. The link between the two substances is this mole-to-mole conversion, which we used right over here in our last example with the mole ratio. These are easy to use. You figure out where do you start at, you figure out where do you want to go to, and you follow the arrows and do the conversions. So in the previous problem, I was given moles of one substance, and I had to convert to moles of the other substance. And it was a one-step problem. And the one-step problem we did used this one conversion factor. So it doesn't take much to figure out then. I could start with grams over here and have to convert that to moles, and moles in the other moles of another substance, and then for moles of that substance in the grams. Eventually we could have 3 steps to this. That's why we learned how to do the daisy chains at the beginning of the year. The only problem we're going to learn how to do in this particular episode is a mole-to-mole calculation that we've just done. So you've already seen it. Let's do one more example using the mnemonic. So this is moles to moles. Here's my chemical equation. Carbon dioxide plus lithium hydroxide makes lithium carbonate and water. You've seen this previously on a slide. This is how at least some of the original NASA rocket ships were able to eliminate carbon dioxide from the atmosphere. It makes this lithium carbonate solid and makes water, so you can use this reaction to actually get drinkable water as well. Alright, question. How many moles of lithium hydroxide? Notice how I put that in words, so you need to be able to recognize the words with the formula. This is lithium hydroxide. How many moles of that are required to react with 20 moles of CO2, which is approximately the average amount exhaled by a single person each and every day? What I like to do when I start this problem is, first of all, we're going to use this mnemonic to figure out where we're starting and where we're going, and I'll show you how I use the chemical equation to my advantage as well. First of all, it was moles of lithium hydroxide are required to react with 20 moles of carbon. My given is 20 moles of carbon. That's the green. I'm starting here. And I'm stopping, and so I put this in red, with however many moles of lithium hydroxide I need. So I'm going from moles of one substance to moles of the other substance, and the two substances we are comparing are carbon dioxide and lithium hydroxide. I can compare any two substances using this. I can compare carbon dioxide with lithium carbonate, with water, whatever I have. But I do have to have an equation, and it does have to be balanced. Now, first of all, I picked numbers on this one that we can just get the answer just by some mental math. If I have 20 moles of carbon being given, let me show you how to use this equation here. One of the things I like to do is I like to write my stuff above the chemical equation so I know what's going on. So I've been given 20 moles of carbon dioxide, and I want to know how many moles of lithium hydroxide there are that I need to react with that. Now, mental math, if I started with 1 mole of this, I need 2 moles of this. So if I have 20 moles of carbon dioxide being breathed out by a single person in a single day, I need twice as much lithium hydroxide. Well, twice of 20 is 40. So just mental math tells you I need 40 moles. From a chemistry standpoint, here's how we're converting it. My given is 20 moles of carbon dioxide. I want to eliminate carbon dioxide by putting moles of carbon dioxide on the bottom. And I want to convert that into lithium hydroxide on top. My numbers now Remember, it's the units that drive this whole thing. My numbers are coming from my chemical equation. So 1 goes with carbon dioxide, 2 goes with lithium hydroxide. All right, solving it's easy. 20 times 2 is 40 moles of carbon dioxide. We figured out where we started at, where we ended at. Write your information on the chemical equation above it. That just helps me. You don't have to do that, but it helps organize your thoughts, in my opinion. Then start setting up your proportions. All right. Thank you very much, and have a good day.